Battle of the metals. Copper versus aluminum. Hey, engineering lovers! Have you ever wondered who the real champion of electrical conductivity is in the world of engineering? Two metals stand out as the gladiators of electricity, the robust copper and the lightweight aluminum. They're everywhere, bringing energy to our homes, industries, and even over long distances across the country. But in a direct battle, which one would come out on top? And more importantly, what is the ideal material for each challenge that electrical engineering presents to us? To understand the differences, we first need to understand the main function of an electrical wire, which is to conduct electricity. A good electrical conductor is like a high-speed highway for electrons, allowing them to flow with as little resistance as possible. The less resistance there is, the less energy is lost as heat and the more efficient the transmission is. There are several metals that conduct electricity, but why do copper and aluminum stand out so much in this scenario to the point of being the main players in our global electrical infrastructure? Well, copper comes in with its impeccable reputation, being one of the best conductors known, second only to silver, which is too expensive for most applications. Its atomic structure allows for an almost unimpeded flow of electrons, which means less energy loss as heat for a given thickness. Copper simply carries more current with less resistance. Aluminum, on the other hand, is a good conductor, but not as efficient as copper. To carry the same amount of current as a copper wire, an aluminum wire needs to be thicker, that is, have a larger gauge. Its conductivity is about 61% of that. It means that, to match the electrical performance, aluminum needs to compensate in volume. In terms of raw conductivity, copper has the advantage due to its natural superiority. Now the battle turns to economy and logistics, crucial factors in engineering projects. Copper, with its higher density, is significantly heavier. In addition, it is a more expensive metal in the global market due to its relative scarcity and the mining and refining processes. This combination of weight and high cost can be an obstacle in large-scale projects, and this is where aluminum shows its strategic strength. It is about 3 times lighter than copper for the same volume. And although it needs a larger gauge for the same current capacity, the resulting aluminum cable is still considerably lighter than its copper equivalent. This lightness not only makes transportation and installation easier, but also reduces the need for more robust support structures. In addition, aluminum is much more abundant and consequently cheaper. Think about the immense high-voltage transmission lines that cut across landscapes for hundreds of kilometers. It would be unthinkable to build all that infrastructure with copper cables, both because of the weight, which would require giant towers, and because of the exorbitant cost. The lightness and cost-effectiveness of aluminum make it the undisputed champion for transporting energy over long distances, which can endure more stress and stay intact under the toughest conditions. Here we assess resistance and adaptability. Copper is a remarkably ductile and malleable metal, which means it can be stretched into thin wires and bent repeatedly without breaking. This flexibility is vital for residential and industrial wiring, where cables need to be bent and installed in tight spaces. It also has excellent mechanical strength, withstanding physical stress well during installation and over time. In addition, its corrosion resistance is superior, and when exposed to air, it forms a stable patina that protects the metal without significantly compromising electrical conductivity. Aluminum, and this is important here, faces its greatest challenges. Its ductility and malleability are lower than those of copper, making it more likely to break or get damaged if bent or handled with excessive force. But the biggest Achilles heel of aluminum is its tendency to oxidize. It reacts quickly with the oxygen in the air, forming a layer of aluminum oxide. The problem is that this oxide is not a good electrical conductor, and in fact it's an insulator. At connection points, this layer can drastically increase the contact resistance, causing excessive heating and, in extreme cases, fire hazards. Two other crucial problems for aluminum are creep and its higher coefficient of thermal expansion. With the temperature variations caused by the flow of current, aluminum expands and contracts more than copper. This constant movement, combined with creep, which is a slow plastic deformation that occurs under continuous load, even below the yield strength of the material, causes aluminum connections to loosen over time. And loose connections are synonymous with increased resistance, overheating, and high risk. Aluminum is also more prone to galvanic corrosion when in direct contact with metals like carbon. When we consider resistance, durability, and connection safety, copper comes out ahead, showing much greater resilience in various conditions of use and handling. And what are the fields of application where each of our competitors stands out as the best choice? Copper is, without a doubt, the king of internal electrical installations in homes, commercial buildings, factories, and electronic equipment. Its high conductivity, ease of handling, durability, and intrinsic safety make it the standard choice for wiring houses, appliances, and machines, where connections need to be robust and reliable. For decades, copper has been unmatched, while aluminum, on the other hand, dominates the large-scale power transmission and distribution scene. Its lightness and cost-effectiveness allow for the construction of long transmission lines and large power feeders in buildings, making the global power grid an economic reality. Without aluminum, the energy that moves the world would be much more expensive and complex to transport over long distances. And why did aluminum almost lose its reputation in residential wiring, and what has changed since then? It's important to revisit a difficult chapter in aluminum history. In the 1960s and 1970s, the rising price of copper led many people to use aluminum wiring in residential installations, especially in North America. However, issues with durability and handling came to light in a dangerous way. The lack of knowledge about the particularities of aluminum and the use of improper connectors. According to him, creep and oxidation resulted in excessive heating at the connections, causing numerous fires. Aluminum's reputation in homes was nearly lost, but engineering has since evolved. Today, there are improved aluminum cables designed to mitigate the problems of the past. However, in residential installations, the preference and recommendations still fall on copper due to its greater safety margin and ease of installation. But I've seen something called alucobre wire being sold. What is that, huh? Alucobre is actually a misleading term for what they really are. Copper-clad aluminum wires, or copper-clad aluminum from the English copper-clad aluminum. This material tries to be a middle ground, combining a lighter and cheaper aluminum core with a thin outer layer of copper. The idea is to take advantage of the peculiar effect where electric current tends to travel along the surface of the conductor to offer better conductivity than pure aluminum, but with lower cost and weight than copper. However, alucobre does not meet Brazilian standards for residential installations and is prohibited due to severe risks. Its higher electrical resistance compared to copper can cause excessive heating, melting of the insulation, short-circuit currents, and even fires. In addition, the thin layer of copper can be easily damaged, exposing the internal aluminum, which, when in contact with other metals and in the presence of moisture, suffers from galvanic corrosion, deteriorating the connection. For these reasons, for electrical installations in homes, Brazilian standards are clear. Only copper cables are allowed, ensuring if you see someone selling alucopper wires on the internet, report it. And if you suspect that you have bought this type of wire, just sand the wires of the cable and see if they start to look different. Silver, which is the color of aluminum, instead of brown, which is the color of copper. So, in the end, who is the real champion, copper or aluminum? The truth is that there isn't an absolute winner in this battle, but rather two specialists in their respective areas. Copper is the champion of versatility and reliability for most indoor and smaller scale applications. This metal protects your home's electrical system, ensuring safety and longevity. Aluminum is the unsung hero of large-scale projects and the champion of cost-effectiveness and logistics for large-scale power transmission. It's what makes it possible to transport and support electricity over long distances efficiently and economically. The key to success, therefore, isn't which metal is better, but which one is most suitable for the specific application. And above all, in an installation done by qualified professionals, using the right materials and techniques for each one. This is the real engineering behind every volt that reaches you. If you've made it this far and enjoyed the video, take the opportunity to subscribe. If you haven't subscribed, like and turn on notifications. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and be remembered in our videos. Before watching the video, did you already have any idea about the differences or risks of aluminum in old installations? Have you ever bought copper wires and received copper-clad aluminum instead? Unfortunately, I fell for that. Share your thoughts in the comments and join the discussion here. There are 2 intriguing videos you should watch to broaden your knowledge and curiosity. If you'd like to support us, please like, subscribe, turn on notifications, or consider becoming a member. That's it, engineering fans. Big hug. See you in the next video.